Hello, class. Happy Wednesday. I hope you're doing fine on your virtual day. Today, our lesson is going to be on one key term, significant figures. Okay? So when we're done with this class, I want you to understand what a significant figure is and be able to identify how many significant figures there are in any number. That's my goal. Okay, so today's homework, we're going to be looking at handout 1.2 and worksheet 1.4. I think those are the next 2 pages in your note guide, the packet, after worksheet 1.3. Okay, so I'm not going to assign all of 1.4, a couple sections from it. All right, so where class is going to begin today is talking about significant. And I want you to think about what does significant mean and where have you heard that? You probably think what comes to my mind is I hear the term significant, I think of significant other. And what does that mean? What is a significant other? Hopefully you understand that a significant other is someone that's important to you. They have great importance in your life. Okay? So when I hear the term significant figure, I should be thinking something that's important, a figure that's important. Now, figure in mathematical terms or science terms is going to represent a number. Okay? So a significant figure, just looking at the word, what does it mean? It means an important number. All right? Now, what we need to do to our audience when we're making measurements, remember, is we need to include how certain or uncertain we are about certain numbers. Okay? And we should understand the fact that every measurement has an estimated or uncertain digit, and that's that last digit. Okay? Now, to better communicate our margin of error, especially when it comes to calculations, we need to follow rules of sig figs, or significant figures. Now, the importance of this is because when you're using these measurements in calculations, we need to keep that consistency to our audience and communicate how certain we are about not only our measurements, but our calculations, including those measurements. Okay? So sig figs, or rules of sig figs, allow everyone that's using their measurements to follow the same rules, and it allows everyone to be on the same page when it comes to how to communicate answers that involve measurements, because our results can never be more precise than our original measurements when we are doing calculations. Okay? So give me an everyday example of that. What do you mean? Well, I have a good example, and it involves a Bazooka Joe comic. Okay, and maybe you've chewed Bazooka Joe gum. I think it runs out of flavor really fast. That's what I remember about it. But I chewed it when I was a little kid, okay? I sometimes get a Bazooka Joe piece of gum. And on those pieces of gum, there's usually a comic or a joke or some sort of saying, okay? So this comes from that. So Bazooka Joe is showing a friend a fossilized bone. And the friend asks how old it is. And Bazooka Joe responds, it's 100 million and 3 years old. How do you know that? Asks the friend. And Bazooka Joe responds, well, the museum expert told me it was 100 million years old 3 years ago. Now, to get the joke here, we have to understand the fact that that 100 million is an estimate. Okay? Every time you go to a museum, you don't see all of the ages of the fossils or the bones changed. Okay? Why? Because a lot of them are estimates, especially the really old ones. If it's 1 million years old or 100 million years old in this case, that's an estimate. I can't add a more specific number to that and say, now it's become more precise. Just like if I estimate from here to New Orleans, it's about 1,200 miles, okay, from my house. I can't step out my front door and now say it's 1,200 miles and 3 feet because I've moved back 3 feet. okay, or north 3 feet. Why? Because that 1,200 miles is an estimate, just like this 100 million is an estimate. I can't add a more precise digit to that and make the original estimate more precise. And that's why we're learning the rules of sig figs, to make sure that our calculations don't become more precise as we proceed. Okay? So, how do I identify first significant figures or important figures? And then next class, I'll see you tomorrow on Thursday, we're going to be using these rules that we're learning today and applying them to calculations. Okay? So we're on handout 1.2. It says HO 1.2 in the upper left corner. Okay? And these are some rules we're going to follow. All right? So to identify a sig fig, the first rule is any non-zero digit counts as a significant figure. So what do I mean by non-zero digit? Any number that's not a zero. So this has 1, 2, 3, 4 sig figs. Okay? Pretty straightforward. Any non-zero digit is significant. Okay? Because otherwise, zeros are typically communicated like, their estimate, about 1,000 miles. Okay? That 1 is what I'm kind of sure about, 1,000. Okay? The zeros are there as just placeholders. Okay? Just like when people say, meet me at 6 o'clock. People don't typically say, meet me at 6:02 if they're just communicating an estimate. Okay? 6 o'clock means around 6 o'clock. Okay? All right. Next, rules that involve zeros, leading zeros. Okay? When you hear the term leading, you should think in front. So zeros in front of a number are never significant. An example of that. Here I have 0.0486. Notice there's a couple zeros in front of it. Those are leading zeros, not significant. Now remember, non-zero digits are, so that's 1, 2, 3 sig figs. Okay? All right. Trailing zeros. Where would these be? Leading is up front, trailing is behind. All right? So trailing zeros right here are significant if there's a decimal point. There's a decimal point, therefore these zeros are significant. They wouldn't be there unless I needed to communicate my precision. Otherwise, I could just put 9.3. I'm putting these extra zeros to show that I know they're important, okay, or I'm certain about them. So this has 1, 2, 3, 4 sig figs. Okay. Trailing zeros without a decimal. So if they're doing nothing but setting a place, okay, or setting a decimal point, okay, if they're doing nothing but holding the value, they're not significant. Easy way to think about that or remember that is if there is no decimal, trailing zeros are not significant. There is no decimal in this number, therefore it just has 1, 2 sig figs. Okay. All right. Captive zeros. Leading up front, trailing behind, captive in the middle. All right, stuck in between two non-zero digits. So here I have 1, 2. Okay, that's one that's stuck in the middle, so that counts. 3, 4 sig figs. Okay. All right. If a number is less than 1, so that is the rules. These are the rules. These last couple are kind of repetitive, but hopefully answer some questions that you may come across. Okay, so if a number is less than 1, then only zeros at the end of the number are significant. So this is kind of saying the same thing as leading zeros are not significant. Okay, we already said that. All right, so let's look. 0.090 has 2 sig figs because leading zeros aren't significant. Zeros after a decimal, if they're trailing, are. Leading zeros, so this has 4 sig figs. Leading zeros, not significant. Captive zeros are, so 1, 2, 3, 4 sig figs. Okay. Last one. I'm waiting for this to get out of my way. Okay. Can't see it. Where are you? 0.00420, I think that says. I'm waiting for, I have something, it's in my way. Has 3 sig figs. The leading zeros are not significant. The trailing zero is. Okay? All right. And again, this is just more practice, more clarification. If the zero has not been measured or estimated, but is just a placeholder, it is not significant. Another way of saying that is trailing zeros are not significant unless there's a decimal. So 2000 technically may have between 1 and 4 sig figs. To simplify things, we're going to say a decimal place is needed to communicate that these zeros are significant. If there is no decimal, we're assuming they're not. So 2000 would have 1. 2000 with a decimal would have 4. Okay? Exact numbers. Now remember, we're dealing with measurements here, with all these. Exact numbers aren't a measurement. I'm counting, okay? This is 1 glass of water. That's not 1 sig fig. I know this is 1 glass of water. I'm not measuring it. I just know there's 1 glass of water, okay? They have an infinite number of sig figs, or sig fig rules don't apply to them. So both of these would have an infinite number of sig figs. The sig fig rules don't apply to them. All right, so an easy way, if you struggle with sig figs, is to follow this two-step process. To follow the two-step process, you need to understand what the difference between trailing and leading is. So hopefully we know trailing is at the end, leading is at the front. Okay? Now, if I want to identify sig figs using this two-step method, you draw a box around all non-zero digits. So there's a box around all non-zero digits, even if it includes other numbers. So 1 box around all non-zero digits. In this case, I would just draw a box around the 5. Same thing here. Here, I would draw around the box around the 101. Okay? Step 1. And this is if you struggle with sig figs. If a decimal point is present, trailing zeros are significant. If not, no. So in this case, I don't need to worry about it. Everything in the box is always significant. So 4 sig figs. The next one, okay? 5. Is a decimal point present? No. Therefore, what's after the box is not significant. Just 1 sig fig. Okay? Number 3. Is there a decimal? Yes, right here. It's kind of covered up, but hopefully you can see it. Therefore, what's after the box is significant. So I have 1, 2, 3 sig figs. Okay? Last one, is a decimal point present? No. Therefore, what's after the box is not significant. 3 sig figs. Okay? All right. So those are our sig fig rules. We're going to practice a few, and then I'm going to show you what to do on your homework. Okay? All right. So how many sig figs? Remember, I would just practice these first on your own, like maybe pause and try to guess, and then I'm going to go over the answer. So how many sig figs here? The answer is 5. Okay? Captive zero is always significant. Trailing zeros are if there is a decimal. So all of these are significant figures. Take a second. How many sig figs? 4. Okay? Trailing zeros are significant if there is a decimal. Non-zero digits, always significant. How many sig figs? 5. Trailing zeros are not significant if there is no decimal. So this one, I'm sorry, this is an error. Okay? There should not be a line right here. There should not be a line right there. Okay? It should just be 1, 2, 3, 4, 5. Okay? All right. Next one. How many sig figs? Oh, this one brings up a point. I have a scientific number, okay, or a number in scientific notation. So this has how many sig figs? Ignore this. Remember, these are just places we're moving the decimal. Only look at the coefficient. How many sig figs are in the coefficient? 1, 2, 3. 3 sig figs. So I just focused on the coefficient. Next one. How many sig figs? 2. Remember, leading zeros, not significant. Next one. How many sig figs? 2. Trailing zeros are not significant unless there is a decimal. 5 pencils. Now, I included pencils here to help you understand I can count 5 pencils. It's not really a measurement. So that would be an example of infinite or exact number. Okay? You're not going to come across a lot of those in chemistry. If you do, I will communicate those clearly. But if you do, hopefully you remember they have an infinite number of sig figs. All right, let's look at worksheet 1.4. We're going to be done with our notes for today. Worksheet 1.4, we're going to do one example from the top 2 sections, which I'm going to assign. Worksheet 1.4, top section, number 1. It says determine the number of sig figs in the following numbers. So all of these, I think it's 1 through 12 or something like that. You need to identify just how many sig figs there are. Okay, so in this case, leading 0 is not significant. This only has 1. Section 2. Determine the location of the last sig fig. Place a bar over it. On the line, if you want to write the number, that's fine. Okay? So in this case, 4070, where would the last sig fig be? I would put a line over the 7. That's the last sig fig in that number. You don't need to write anything on the line if you want. Maybe it'd be good practice to write how many sig figs are in the number, but that's up to you. Okay? So what I'm assigning, this is worksheet 1.4, section 1 and 2. That's 24 problems on identifying sig figs. How many sig figs are in a number? Okay? Good luck. If you have any questions, email me. We can set up a Zoom meeting. Otherwise, I'll see you on Thursday, and we're going to start using these sig fig numbers in our calculations. Please stick around for our quiz. All right, that's class today. Hopefully it went well. If you have any questions, please let me know.